Hi everyone, welcome to the next video in this series. So in this problem what I'm going to do is actually calculate a two-dimensional conservation of momentum problem. So if you notice here we have two objects of different masses and they're purposely set off, if you notice the 8 is a little below the 2 right here, so that they will go off at different angles. So the question in this is solving for the velocity of the 8 kilogram ball after the collision right here. So the method that we're going to be taking, I'll just quickly go over the method, is that we're going to first, oops, sorry, my pen's acting up a little bit. So first we're going to basically look at the components of our momentum. So we're going to look at the initial xi and make any assumptions with the xf. We're going to look at the horizontal momentum to help us solve it, but then what we'll have to do is notice that this is part of a triangle, right? So in other words, we're going to have to use the Pythagorean theorem. So from this we can get the velocity x and y components to solve a problem. So let's figure out what's going on here. So let me just get some space. Alright, so let's look at the horizontal parts first. Doesn't matter the order, you can go vertical, but let's look at the horizontal part. So the initial horizontal part, I'm going to put it underneath here. And we know by conservation it has to equal to the final horizontal parts. So let's look. This object, I notice that it has a completely vertical velocity right here. So in fact, I could write the momentum of its horizontal part will look like this. It'll be m1. I'll write it symbolically first. v1x, and then same thing, plus m2 v2x. And these are, of course, all the initial parts. Has to equal m1 v1 xf plus m2 v2xf. So let's go ahead and add and look at it this way. So if you notice, our mass wants to be 2 kilograms times the horizontal component of the velocity. Like I said earlier, this is actually completely horizontal, so this will be, in fact, just 3 meters per second like this, plus 8 kilograms. Now this object's at rest, so its horizontal component is also at rest. So for completion, I'll put that there, but as always, you can shortcut by taking that term out. So let's see what happens to the first velocity. So m1 is the same mass, we have the same mass. But let's look at the x component of this velocity here. So notice that we have a velocity of 2 meters per second. I'm going to draw it bigger even though it's right here. I'm just going to draw it so we can see it better. But we can't use that for our problems. We need to use the triangle that it makes. We need the Vx and then we need the Vy, right? And these are the final components of each, like this. So if you notice, to get Vfx right here for the first mass, notice that this is next to our angle, so this will be a cosine. So Vfx is going to be 2 meters per second times the cosine of 50 degrees, because we want just the horizontal part of this. Now you can solve it here and get a number and plug it in, or you could plug it in down here, it doesn't matter. I'm going to plug it in down here, so 2 meters per second times cosine 50 degrees plus the mass of the second object times its final velocity in the x. So what this solves for, that value that I just wrote down, is the x component of this velocity right here. So Vx final for 2. And just to be complete, this is Vx final 1. So these are two different things. But notice this thing is going down and to the left. So what that equation just gives us is the horizontal part of that. And that's what we have there. Now, it's not the total velocity, but we can build the velocity later by finding the horizontal component and the vertical component and making it into a triangle and using the Pythagorean theorem. So I'll show you what we're going to do. So let's solve this out. So this becomes 6. Let me use the right color though. That's just 0. So let's go ahead and calculate this out. There we go. Talking. Okay, I'm in degree mode. So let's do it. 2 times 2 times cosine 50, 2.57. Plus 8 V2fx. So if I move that over, I get 3.43 kilograms meters per second equals 8 kilograms V2fx, like that. And let's go ahead and divide that by 8 to get our final velocity. So 0.43, I'm going to round, meters per second, is the final x velocity, like this. So since this is positive, this is moving to the right. So this answer is also positive, which is modeling our situation, so that's good. So what did I just solve for? This is the 0.43 meters per second. Again, it's not the answer to the question. This is the answer, or what it wants. We have part of this answer. So our next step is to use, so we did that, so now we're going to use this to find, basically, if you notice, sorry I'm drawing over that, is we're going to find Vy final 2 with this. So we found V2x final using this, and we're going to find V2y final using that. So let's go. I set up the exact same expression, but now we're looking vertically. So we need the initial sum of the y components and the final y components. So it looks like this. We'll do it first as a conceptual, not conceptual, but mathematical. So M1, V1, Y, I, 1 initial. Sorry, there's a lot of symbols there. 2, the second velocity's initial y component. So let me just be consistent. I like it written better like that. It means the same thing. I'm just being really picky for picky's sake, but the mass 1 times velocity 1 initial in the y plus mass 2 velocity 2 initial in the y has to equal mass 1 velocity 1, keep track of this, 1 final y plus mass 2 V2 final y. So let's analyze our motion. So if you look at this, there's no y motion in our first mass because it's not moving up or down or at an angle. So interestingly enough, if I apply the equation for this one, it's going to be 0. Now mass 2 is at rest, so that's also 0. Fun, right? So that's fine. This just nicely becomes 0. It's easy. Like that. Now let's look here. Mass 1 is the 2 kilogram object. But just like we did before, we're going to get the vertical component of the 2 meters per second velocity that we have here. So Vy final, so it's opposite the angle, so it's going to 2 meters per second times sine 50 degrees. So, but I did that quickly, hopefully that makes sense. So that's what goes here. 2 meters per second times sine 50 degrees plus 8 kilograms V to F final, because we don't know that variable, like that. So let's go ahead and simplify 2 times sine of 50, 3.06 kilograms meters per second, like that, plus 8 kilograms V to Fy. So that means basically that this moves over and becomes negative. And then, of course, to get the variable, I'm going to divide the 3 by 8. Oops. And it becomes negative. Negative 0.383, sure, meters per second equals V to Y final. So notice that it's negative, which means in a vertical sense this is moving downward, or south, or whatever you want to say. And look, it matches, which is good, because we do have it being modeled downward, so we got this correct. So negative 0.383 meters per second, like that. So cool. So like I said, right now we just solved for the components that make up this velocity, but the real question is, what is V? So we solve V by using a triangle. So here's the way it looks. I'm just going to redraw the triangle just so it's out of the problem. Question's looking for V. We have the legs, or the, whatever you want to call this, we have the parts of the triangle. So this one was 0.43 meters per second. This one we calculated as 0.383. Now I'm going to ignore the sign because I'm modeling the direction right now, which is fine. So to get V, I can use the Pythagorean theorem, so I will in one step here. 0.43 meters per second squared plus 0.383 meters per second, whole thing squared. Square root the answer to get V. Double equal. Oops. Okay. So let's do that. So square root 0.43 squared plus 0.383 squared, square rooted. My final velocity is 0.58 meters per second. Now it's not complete, so I'm going to grab an angle. Now the angle I'm going to grab is going to be the angle that I think makes most sense in the problem. So I want this angle because then I can compare it to what it was originally moving to. This angle is not really helpful, so I'm going to get this angle right there. So, doing a little bit of trig, we can find that angle. Give me 1 sec. Opposite adjacent, so if I take the inverse tan of the opposite over the adjacent, I could solve for angle. Now I ignored the sign again, if you notice right here, because when I do this, if I put the sign in, it makes it negative, which means it's below the axis, which I know already. So I'm just going to find the magnitude and say below the axis. So I'll just take that step right there. So inverse tangent 0.383 divided by 0.43. So the angle is 41.69, so I'm going to round to 7, so 41.7 degrees. So, as always, a really good answer is a complete answer, so the final answer would be the velocity is 0.58 meters per second at 41.7 degrees below the horizontal. That would be the official answer to this question. because we have the information about the velocity and information about the angle. I hope you found this helpful.